After studying this module, you should be able to know the significance of heavy metals, some notable heavy metals responsible for substantial poisoning, their forensic significance of heavy metal poisoning. Heavy metals are naturally occurring elements and are existent in variable concentration in all ecosystems. There are a vast number of heavy metals. They are found in elemental form and in a variety of other chemical compounds. Those that are volatile and those that turn out to be attached to fine particles can be extensively transported on large scales. Every single form or compound has different properties which also affect what happens to it in food's web and how toxic it is. Human activities have significantly changed the biochemical cycles and equilibrium of some heavy metals. Heavy metals occur as natural elements of the earth crust and are obstinate environmental pollutants as they can neither be degraded nor be destroyed. To a small extent, they enter the body system through the food, air and water and accumulate over a period of time. The term heavy metals denotes to any metallic element that has a comparatively high density and is toxic even at low concentration. However, being a heavy metal has little to do with density but concerns chemical properties. Heavy metals include lead, mercury, cadmium, copper, zinc, arsenic, iron, chromium, silver and the platinum group elements. Environment is defined as a total of conditions surrounding an organism or collection of organisms, particularly the arrangement of external physical surroundings that affect and impact the growth, development and survival of organism. It comprises of the flora, fauna and the abiotic and contains the aquatic, terrestrial and atmospheric environments. Heavy metal pollution of surface and underground water sources results in considerable soil pollution, and pollution increases when unearthed ores are dumped on the ground surface for manual dressing. Forensic issues. The main anthropogenic sources of heavy metals are various industrial processes, mining, foundries and smelters, combustion of fossil fuel and gasoline, and waste incinerators. The chief heavy metals of concern are mercury, cadmium and lead because they are the most toxic and have well-known severe effects on human health. Environmental exposure to high concentrations of heavy metals has been linked with, for example, various cancers and kidney damage. Environmental pollution by heavy metals is very conspicuous in areas of mining and old mine sites, and pollution decreases with increasing distance away from mining sites. These metals are leached out and in slopy areas are carried out by acid water downstream or runoff to the sea. Through mining activities, water bodies are most emphatically polluted. The potential for contamination is increased when mining exposes metal bearing ores rather than natural exposure of ore bodies through erosion, and when mined ores are dumped on the earth surface in manual dressing processes. Though rivers and streams, the metals are transported as either dissolved species in water or as a primary part of the suspended sediments. They may then be stored in river bed sediments or percolate into the underground water, thereby polluting water from underground sources. Many wells and the degree of contamination will depend upon the proximity of the well to the mining site. Wells situated near mining sites have been stated to have heavy metals at levels that can exceed drinking water standards. Let's study some prominent heavy metal poisons. Arsenic. Arsenic is extensively distributed in the environment, particularly in rocks, sediments, and some water supplies. A number of inorganic arsenics have been predominantly long historical use as drugs and poisons. In the 18th century, Fowler's solution, which is 1% weight by volume potassium arsenite, was used as a cure-all and remained in use until the 20th century. Organic forms of arsenic occur naturally in seaweeds, fish and shellfish, but are comparatively non-toxic. Different forms of arsenic have broadly differing human toxicity. These forms are also controlled by the body in different ways, which causes problems in their determination and in the interpretation of laboratory findings, particularly when the source of arsenic is unknown. Arsenic has three common valence or oxidation states: 0 in metalloid, 3 plus in arsenite, and 5 plus in arsenate. The trivalent inorganic salts of arsenic, for example, sodium arsenite, are the most toxic and may cause serious toxicity or death after acute ingestion of relatively small doses, for example, less than 200 mg. Inhalation of arsine gas may cause massive hemolysis, renal and other organ failure, and rapid death as in industrial accidents. The signs and symptoms of chronic arsenic poisoning, that is arsenic oxide, are extremely complex and include weight loss, malaise, hyperpigmentation of the skin, transverse white lines on the nails, liver damage, changes in the blood, peripheral neuropathy, and increased risk of skin and liver cancer. Acute poisoning is characterized by bloody diarrhea, vomiting, excruciating abdominal pain, circulatory collapse, and coma. Skin and respiratory cancer is another feature for chronic arsenic exposure. Hair and nail analysis has also been used in diagnosis and evaluation of chronic arsenic poisoning, particularly suspected homicides. However, there may be problem distinguishing external contamination from ingested arsenic. Normal values for arsenic are less than 10 micrograms per liter in blood and urine, but elevated values can be seen after ingestion of seafood and where there is occupational exposure, and elevated levels of arsenic potentially arising from these sources should be taken into account when assessing measured arsenic concentrations. In cases of acute inorganic arsenic poisoning, concentrations more than 500 microgram per liter may be seen in blood and urine. Cadmium. Cadmium and its salts and alloys are used in the manufacture of nickel-cadmium batteries, pigments, anti-corrosion coatings, and special alloys. Acute or chronic ingestion of cadmium salts is extremely rare, but reported signs and symptoms include nausea, vomiting, hemorrhage, gastroenteritis, and general organ failure. Most of the toxicological problems associated with cadmium are the result of occupational and environmental exposure and have been known for many years. These include pneumonitis and emphysema from the acute inhalation of cadmium fumes and more long-term renal impairment. Water supplies contaminated with industrial cadmium in Japan led to accumulation of the metal in rice and other dietary sources with subsequent human poisoning on a vast scale. Those affected developed renal damage, skeletal deformities and caused by disturbances of calcium and phosphate metabolism and severe back and leg pain. This painful condition became known as itai or ouch ouch diseases. For those not occupationally exposed, the major source of cadmium remains the diet, although it is absorbed poorly from the gut. Inhalation of tobacco smoke is, however, an important source of cadmium exposure, as the bioavailability of cadmium via the lung is very high and heavy smokers may have blood cadmium concentrations at the limit of current occupational guidance values. Individuals who have a long history of excessive occupational cadmium exposure can have a high body burden which persists into old age. Elevated blood and urine cadmium concentration may be observed many years after the cessation of exposures in such individuals. Lead. The toxic effect of inorganic lead have been known since antiquity, but this metal still presents a significant public health problem in many parts of the world. Lead compounds continue to be used as a component of some traditional medicines. Acute lead poisoning is relatively uncommon, however, and most symptomatic cases result from chronic ingestion or inhalation of lead fumes or dusts during occupational exposure or use of lead containing traditional medicine and ingestion of lead paint chips or dust from old or substandard housing. In adults, barely 10% of the ingested lead is absorbed from the gastrointestinal tract, but in children this proportion may be much higher. However, the bioavailability of ingested lead may be influenced substantially by the individual's diet and nutritional status, for example, iron and calcium deficiency. The experimental diagnosis of lead poisoning can be challenging when there is no clear history or apparent source of exposure, since many of the signs and symptoms of chronic lead poisoning are relatively non-specific. For example, tiredness, abdominal pain, anorexia. Wider ranging laboratory investigations therefore play an essential part in the diagnosis and management of lead poisoning and also in the assessment of occupational and environmental lead exposure. Although lead can be found in most tissues of the body, over 90% of the body burden is deposited in the skeleton as insoluble lead phosphate. Following chronic exposure over many years, as occurs in some industrial workers, tissue stores such as bone become saturated. Lead is poorly excreted from the body, the most important route being via the kidney. Copper. Copper is an essential but potentially very toxic trace element with a recommended intake of approximately 1.5 to 3.0 milligram per day in adults. Wilson's disease is an important genetically inherited disorder of copper metabolism in which there is an inability to transport and excrete copper from the liver into bile. There is some evidence that excess environmental exposure to copper in drinking water or diet from copper or brass cooking pots may lead to copper-related liver disease in babies and young children. Copper toxicity has also been found in patients who undergo dialysis with defective copper-containing dialysis membranes. Occupational exposure to copper compounds is relatively rare. The main risk is associated with copper fumes in smelting furnaces, which lead to respiratory illness and metal fume fever. Copper-related liver and respiratory disease has also been reported in vineyard workers who spray copper-containing fungicides like Bordeaux mixture. Toxicity has also been reported following occupational exposure during the application and removal of anti-fouling paints in ship repair facilities. Acute copper poisoning may sometimes be seen in cases of accidental and suicidal ingestion of copper salts and solutions, particularly water-soluble salts such as sulfate, chloride or acetate. The signs and symptoms of acute copper poisoning are gastrointestinal irritation, abdominal pain, nausea, vomiting, diarrhea and gastrointestinal bleeding. In severe cases, they can lead to hypertension, shock, cardiac failure and death. Mercury. Mercury has been used in the manufacture of thermometers and a range of other scientific and medical instruments for hundreds of years, but this use has now declined. Elemental mercury continues to be used widely across the world in a number of developing countries by substances gold miner using the mercury amalgamation process. Mercury and its compounds have also been used widely in the chemical industry and in the manufacture of drugs and pesticides. Some compounds such as ethyl mercury derivatives have historically been used as preservatives in the manufacture of vaccines used in infants and young children. Mercury containing dental amalgam fillings is still used in many countries, although their use, particularly in children, does not appear to be associated with a risk of neurotoxicity. The toxicity of mercury and its compounds is influenced greatly by the chemical form and valence state. The most toxic form of inorganic mercury are its divalent water-soluble salts, particularly mercury chloride, which was used as a disinfectant in earlier times. The fatal dose of mercury chloride is less than 5 grams oral in an adult, which lead to its popularity as a homicidal and suicidal poison and gave it its popular name corrosive sublimate. There is a significant toxicity associated with both acute and chronic inhalation of elemental mercury vapor, since mercury has a very high vapor pressure at normal room temperature. Broken mercury thermometers can constitute a serious risk in children through inhalation of vapors, particularly in a home environment such as a bedroom. Organic forms of mercury such as methyl mercury are strongly neurotoxic and, being relatively lipid soluble, can accumulate in fatty tissues of the body such as brain. Large-scale environmental disasters have occurred, such as that involving the Minamata Bay area in Japan, where thousands of people died or became severely incapacitated. This was caused by the factory discharge of industrial waste that contained mercury, which settled into the sediments of the bay and river and was methylated by microorganisms. The methyl mercury became incorporated into the fish diet, on which the residents of Minamata largely existed, and this resulted in so-called mini matter disease. The signs and symptoms of acute and chronic mercury poisoning mainly involve the CNS, kidney or skin. Characteristic symptoms in children include acrodynia or pink disease, which includes signs such as pink hands and feet, which was historically associated with the use of mercurous chloride in teething remedies. Iron. Iron is widespread in nature and is found in rocks and minerals and in a wide variety of foodstuffs. It is essential to the functioning of the body. Accidental or suicidal ingestion of iron preparations in adults is rare, but poisoning is commonly seen in young children after the accidental ingestion of iron tablets. Over-the-counter products contain various iron salts, for example, sulfate, fumarate, gluconate, and many are slow-release preparations. More recently, a number of non-ionic iron preparations have been introduced. For example, carbonyl iron and polysaccharide iron that contains a much greater proportion of iron, which is only slowly converted to ferrous ions. The clinical presentation of iron poisoning and its time course has been quite complex and go through different phases, particularly when dealing with young children if ingested dose is very high. Acute iron poisoning has assumed grave significance in recent years and cases of accidental poisoning are being reported with alarming frequency in young children. Since most iron preparations, syrups and tablets are brightly colored and pleasantly flavored, they constitute an irresistible fatal attraction for these innocent victims. Let's summarize that heavy metals are naturally occurring elements are present in varying concentration in all ecosystems. There is a huge number of heavy metals. They are found in elemental form and in a variety of other chemical compounds. Some heavy metals like iron, zinc, calcium and magnesium have been stated to be of bio-importance to human and their regular medicinal and dietary consumption had been recommended. But the biotoxic effects of many of them in human biochemistry are of great concern. Heavy metals occur as natural constituent of the earth crust and are persistent environmental pollutants since they cannot be degraded or destroyed. To a small extent, they can enter the body system through food, air and water and bioaccumulate over a period of time. Industrial products that are used in homes and which have been produced with the heavy metals are sources of human exposure to such heavy metals. Mercury exposure is through disinfectants, antifungal agents, toiletries, creams and organometallics. Cadmium exposure is through nickel or cadmium batteries and artist paints. Lead exposure is through wine bottle wraps, mirror coatings, batteries, old paints and tiles amongst others. Workers of the mining and production of cadmium, chromium, lead, mercury, gold and silver have been reported to be thus exposed. Also, inhabitants around industrial sites of heavy metal mining and processing are exposed through air by suspended particulate matters that are known as SPM.